Using Dragon Naturally Speaking is both faster and more accurate than my typing, even though I cannot, cannot properly train it to type AALL. Delete AALL. All caps. Alpha, Alpha, Lima, Lima. Caps off, period. Click Page Layout. Click Margins. Click Last Custom Setting. Switch to Dictation Mode. Click Page Layout. Switch to Command Mode. Click Page Layout. Click Margins. Click Normal. Switch to Normal Mode. Period. The digital divide can be described in different ways, but in its simplest formulation, it is the separation between those who have access to the benefits of the digital transition and those who do not. In this presentation, we are going to discuss 3 types of assistive technology that can help those with disabilities cross the digital divide in the context of computer-based or web-based information. Speech-to-text, text-to-speech, and eye-tracking technology can increase the flow of information to those for whom it would otherwise be limited. Dragon Naturally Speaking is an example of speech-to-text, as are closed captioning, assuming that you are not using a transcriptionist, and cell phone voice commands, all of which trace their origin back to 1952 and the first speech recognition machine, which was a mechanical device built by Bell Labs to recognize spoken digits. It was meant to be a prototype as the first step in automating directory assistance. Over time, of course, speech recognition researchers started using computers, but they discovered that creating a set of English grammar rules was still too complex, so they taught it math instead. Now, much of the math pertains to a statistical model known as a hidden Markov model. I'm still catching up on the math, but describing its purpose is simple. By treating speech recognition as a statistical process and using probability to predict the next word, you save a sufficient amount of processing time to allow for real-time processing. The man who first applied the hidden Markov model was Dr. James K. Baker, who was doing his doctorate at Carnegie Mellon and applied the hidden Markov model to an early prototype he called Dragon. But it wasn't until 1997, 22 years later, that he successfully commercialized a continuous speech recognition system, because it took that long for computer processing power to support the requirements of Dragon Naturally Speaking. Despite what you may have heard, even though Windows speech recognition is part of newer Microsoft operating systems, you won't be throwing away your keyboard anytime soon. And I'd like to start demonstrating the what I would call inherent limitations of speech-to-text by playing the mouse grid demo. Mouse grid 3, 9, 8, 3 click. Mouse grid is for those instances when it doesn't work to say the name of the link to click it. While the mouse grid demo helps illustrate that a sufficiently motivated individual might be able to train Dragon to go virtually hands-free, it also illustrates why most people won't take that time. It took about 8 seconds for me to click the appropriate link through speech recognition, and I did it in about 2 seconds using the mouse. The use of speech recognition could be a problem if you work in a cubicle rather than an office. And even if you work in an environment where higher noise levels are tolerated, you're probably using your voice to speak on the phone. And even if you're not using your voice to speak on the phone, you may want to be using your voice for something other than typing on the computer, and these limitations would exist even if speech recognition software was perfect. Now I would like to switch to text-to-speech, aka speech synthesis. And I want to start the discussion by playing for you footage of the first speech synthesizer ever built, one that was demonstrated at the 1939 World's Fair.
Let's see how you put expression into a sentence. Say, she saw me, with no expression.
She saw me.
Now say it in answer to these questions. Who saw you?
She saw me.
Whom did she see?
She saw me.
Did she see you or hear you?
She saw me.
The first commercial product was introduced in 1976, just a year after the fundamental breakthrough in speech recognition. And I believe there are 2 reasons that speech synthesis was commercialized more quickly than speech recognition. First, speech synthesis didn't have to worry about accents or something like a tone of voice disturbing the input. And second, written speech is far more grammatical than spoken speech. This means speech synthesis can make use of both mathematical models and English grammar rules. Now, a company called DeckTalk introduced speech synthesis products in about 1983, and one of the voices that came with their products was called Perfect Paul. Perfect Paul has still been in use, even in recent years.
The appeal of The Simpsons is that the characters display all the traits we see in ourselves. In particular, Homer is the ultimate young middle-aged man, a father who repeatedly fails his kids, messes up at work, and is always trying to get something for nothing.
It's safe to say that speech synthesis has created functional products. Some of you may have heard that the Amazon Kindle was the subject of a controversy regarding its use in the university classroom. Because its text-to-speech functionality was not available when it was first powered on, it was inaccessible to the blind, though Amazon later corrected this issue. And one of the issues I discussed when I wrote the program description was whether it was too expensive to integrate an item like speech synthesis into an ordinary consumer product.
Thank you for purchasing Amazon Kindle. You are reading the Welcome section of the Kindle User's Guide. This section provides an overview of Kindle and highlights a few basic features so you can start reading as quickly as possible.
Similar voice, similar price point. I suspect that copyright concerns rather than cost concerns delayed the Kindle accessibility fix. And this brings us to screen readers and the PDF format.
Please Assistive Technology Wiki Accessibility Report Introduction. The link CSSIS Adaptive Technologies Committee applied the link Web Content Accessibility Link Guidelines version. Link 2.0 in evaluating the committee's own assistive technology pages on the CSSIS Wiki hosted by PB Works. Alert. Heading Level 1 Assistive Technology Wiki Accessibility Report. Heading Level 2 Introduction. Missing link text. Heading Level 2. Error list. Heading Level 3. Practical effect. Heading Level 3. Heading Level 3 Practical Effect. Though the search box has a title that enables screen readers to identify it as a search box, the title does not indicate what is being searched.
There are two caveats to the accessibility of the PDF format. First, Adobe and the screen readers began supporting PDF accessibility relatively recently, which means that some users will have older versions either of Adobe Reader or of screen readers. Second, if the document is scanned in rather than created from something like a word processing document, screen readers will still be unable to read it, and either one of these may explain the experience of blind attorney Isaac Lidsky, who was profiled in the Spectrum. The article mentioned that PDF was inaccessible to him. Before moving on to the web page demo, I wanted to talk for a moment about how screen readers access web pages in general. Screen readers look at the underlying markup language rather than what the human reader is seeing. This means four things. First, it follows the keyboard focus order or the tab index order. Now, the keyboard focus or tab index order refers to how the tab key will move through the screen if you're using the keyboard to move through the screen. And if the keyboard focus order or tab index order is significantly different than the way a sighted user would read the page, that can render a page less accessible. A screen reader can skip between headings or lists even in the absence of a skip navigation link, provided those headings or lists are structured properly. And of course, one of the problems is that many times they are improperly structured. This happens most often because people use headings for layout rather than document structure. Responses to images are inconsistent without alternative text. A screen reader may read the file name, which can be very different from the image itself, or it may read nothing at all. And responses to input boxes are inconsistent if there are no labels. One common scenario would be a search box, and the screen reader user won't know that the search box is a search box unless and until they hit a labeled search button, at which point they say to themselves, "Oh, that editable text field I heard just a moment ago was a search box." And then they have to go backwards in order to type in their search. Hidden Heroes is a Flash-based website that salutes the obscure inventors of ordinary items. It was a 2011 Webby Award winner for Best Navigation and Structure. The first part of the demonstration shows how a sighted user would use the website. And the second part of the demonstration shows how JAWS would access, or in this case not access, the website, even though it is possible to make Flash accessible to screen readers. Ow!
Toolbar Home tab, CN tab, Vitra Design Museum button. Tab. Tab, unlabeled 5 button. Tab. Tab, unlabeled 35 button. Tab, unlabeled 41 button. Unlabeled 41 button. There are no headings on this page. Unlabeled 47 button. There are no tables on this page. There are no frames on this page. Unlabeled 54 button. No more lists found. Tab. Tab. Untab. Unlabeled 3 tab. cnt.php v equals 3.0 and amp.
These heroes are still hidden from screen reader users. Which brings us to the Web Content Accessibility Guidelines, the recognized international standard for web accessibility. Now, I'm already working on a program for proposal for next year addressing the guidelines. But the important point to note today is that the Justice Department's web accessibility regulatory proceeding may implement many of these guidelines as ADA regulations, and that's one way the law can assist accessibility. But I looked at the front pages of all ABA accredited law schools, and only one of them appears to be in compliance with every relevant guideline. Now, there were 4 additional schools whose front pages passed one of the commonly used accessibility validators. But the validator does not check for every guideline. And presumably the other schools were unaware of the guidelines not checked by the accessibility validator. There were an additional 15 schools who had what I would call near misses. That is, the number and type of errors suggested that they were at least trying to make their web pages accessible. One of the issues I raised in the program description was whether this lack of awareness of the guidelines could account for this, and I believe the answer to that question is yes, because not even the National Federation of the Blind website is in full compliance with these guidelines. It has color contrast errors or pages where the color contrast is not in compliance with the relevant guidelines. It also lacks a visible focus box. Now, the National Federation of the Blind Constitution and bylaws require that a majority of its membership and officers be legally blind, which means that the majority of their members are not those who would be benefited by the guidelines on color contrast and visible focus boxes. So it is possible that few enough low vision users who would benefit have visited the site to make the NFB aware of these issues. And there are people out there who would benefit from those guidelines, and I have known some of them. Before leaving text to speech, I want to take just a moment to talk about the inherent limitation of it, which is that most people can read much faster than they can listen, which means that while a screen reader is useful as a proofreader, it's probably not going to become a mass market device. Due to time constraints, we're only going to spend a brief moment with eye tracking.
I've tried using a switch, and before I had lost my voice, I used voice activation. But the eye control is by far the most convenient method for me.
While it is clearly functional for those who have no other usable means of input, the obvious drawback with eye tracking is that most people want to use their eyes to do something else. And I'm very skeptical that the eye tracking laptop prototype will ever become a production model for that reason. The ultimate solution to the obstacles facing the kinds of assistive technology we have discussed in this presentation are better mathematical models, more computer processing power, and in some cases better data sets. But the limited mass market appeal of these programs also tends to limit both public and private research dollars. And I want to give you one further example regarding speech to text. Radiologists are especially interested in and frustrated by speech recognition. And my brother, the OBGYN, says that this is because radiologists read charts and dictate reports as their main function. Thus, they make more use of medical transcriptionists than most other doctors. They also have the stereotype of being tech geeks, which makes them the logical audience for expanding speech recognition beyond its use as merely an assistive technology. Now, the rights to Dragon Naturally Speaking are currently held by a company called Nuance, and despite the fact that Nuance has created a product specifically for radiologists that they market specifically to radiologists, they're having a very difficult time cracking that market. Dragon Naturally Speaking really can get close to 99% accuracy once you get used to the program, once you've trained it. But even a 1% error rate frustrates potential users who don't want to spend any training time at all. And Nuance is a relatively small company with limited R&D. And while they continue to file speech recognition patents, they don't appear to be on the verge of a major breakthrough. Windows speech recognition is to Dragon Naturally Speaking as Microsoft Paint is to Adobe Photoshop. It comes with the operating system. It is a functional program. But those who can afford to do so would pay for the better product. Microsoft also continues to file speech recognition patents, but they don't appear to be on the verge of a major breakthrough either. Now, earlier I mentioned some other speech-to-text examples, which included cell phone voice commands and automatic closed captioning. Well, cell phone voice commands work fairly well. But the reason they work fairly well is because the vocabulary is limited. And if you limit the vocabulary, you've given yourself a much easier task. Now, Google is trying to create what it calls a speaker-independent speech recognition program, which means they're trying to cut down on the training time. In fact, they're trying to cut out the training time. But based on my testing so far, the accuracy rate is only 85 to 90%, which is actually higher than most people would think it would be, because most people are focused on the sometimes crazy errors it makes. But 85 to 90% is low enough that even I find it annoying. And I suspect that Google is trying to improve their data set rather than trying to produce a product that is functional today. If the web accessibility regulations ultimately require closed captioning, this may spur further development of speech recognition. Now, despite these challenges, I would like to end my presentation on a positive note and reiterate what I mentioned at the beginning of the presentation. The assistive technologies discussed in this presentation are sufficiently usable to make a real difference in bridging the digital divide and providing those with disabilities access to information and resources they would not otherwise have. Thanks for watching. Thanks for listening.